So in this question, I need to find the value of when we sum this input here, 20 times a half to the power of r, from r being 4 to infinity. So we can see that this is an infinite sum. And then the second part, we need to sum when n equals 1 to 48. The input is log base 5 of n plus 2 over n plus 1 and show that that equals 2. So that's our challenge for this question here. So first of all, let's look at this one. So my first interest is what's going on for the summation here. 20 times a half to the power of r. Now I can see here this is a geometric series with a ratio of 1/2. Well, that ratio of here is 1/2. When the absolute value of that is less than 1, what we can do is the infinite sum, which I'll call S infinity, that equals the first term divided by 1 minus this ratio, which is 1/2. And that will give us our infinite sum. So let's work out what that is. Well, the first term is when r equals 4. So my first term, that equals 20 times 1/2 to the power of 4. Okay, so let's go with that. So that equals 20 times 1/2 to the power of 4 over 1/2. Okay, now 20 divided by 1/2, that's going to give me 40. So I can now write this as 40 times 1/2 to the power of 4. So that equals 40 times 1/2 to the power of 4. So 1/2 to the power of 4, that's going to give me 1 over 16. So therefore I've now got 40 times 1 over 16. Now 40 times 1 over 16, 40 divided by 16 is going to give me 2.5. So that equals 2.5. So that's the answer to the first question. Now this one here, let's have a look. First of all, what's going on? So let's write out some of the terms. So log base 5 of n plus 2 and n plus 1 when n is 1. So then I've got 3 over 2. That's my first one. Then let's add the second one. So when now n is 2, I've got 4 over 3. So now I've got log base 5 of 4 over 3. And then let's do another one. So the next one is log base 5. So now when n is 3, I've got 5 over 4. And that will keep going on and on and on and on until I get to 48, which will give me plus log base 5. When n is 48, I've got 50 over 49. Okay, right. Now, one of the properties of logarithms is when we add them, what I can do is put them all into one logarithm and then multiply them. So this then becomes log base 5 of 3 over 2 times 4 over 3 times 5 over 4, and that will keep going on and on. And let's put the last but 1 in. So when n is 47, I've got 49 over 48. So times 49 over 48. And then this last one is 50 over 49. Okay, now what's going on here? Now this looks like a telescoping series. So a telescoping series, what happens is we can cancel stuff out, then hopefully we just end up with a first term and a last term. Now I can see here I've got 3 times something and divided by 3. So these 3's can cancel out. Next term I've got a 4 here and a 4 here. That can cancel out. Now the one after this would be 6 over 5. So that 5 and that 5 there, which we've not written down, would also cancel out. And it would go on and on and on and on. And the one before here would be 48 over 47. So the 48 would cancel out with that one. Then I can see I've got 49 and 49 will also cancel. Okay, so now with all that cancellation, after all that, all I'm left with now is log base 5 of 50 over 2. Now 50 over 2 we know is 25. So now I've got log base 5 of 25. Now 5 squared is 25, so then that equals 2. And that is exactly what we wanted. So we proved that that would equal 2. Okay.